Hello, welcome and good evening to the next episode in our Let's Code MS-DOS series. So last time we got the program to be like this. We had two pedals that you can move independently, so we can have a two-player game. But there's no score keeping, no end of game or similar stuff. And a few more graphic tricks that we can add. And I think doing all of this will probably take too long for one episode, so I'll do it in 2 episodes. And today we will do some more graphics tricks, and in the last episode I'll show you how to print the score and handle the end of the game basically. And this will be our season 1 basically. More advanced topics like mouse support, flicker-free animation, and maybe even a bit sound will be something for the next season, but I will have to prepare a bit because some of the stuff I don't remember from back in the day. I will have to read up on that, because honestly what I'm doing here is more or less taking all the stuff that's still in my head, looking up a few of the values like the port numbers that I need for the VGA, but it's all stuff that I already did like 20-30 years ago as a kid, like a student. And yeah, so what can we do today? We already learned how to set the palette, and it would be nice to be able to more softly fade the image in and out, because this just makes boop and here it is, and that's not very nice, right? So first of all, another thing is, since we can't do page flipping yet, you can always see like the screen building up in the beginning. If I repeat this, I made an oopsie. Let's try again. So you can see how the screen builds up. I don't want you to see that, right? So we will basically do a black palette. How we can do it like this: set black palette, no need to waste memory. And it will be very simple. We can copy the set palette function and just write out zeros. And if we do this right before we draw anything, we should actually be fine. Let's do it like this. Set black palette. Exactly. And then after we draw the background, we will actually do this. The original palette, right? So, was this better? Was this any better? Oh, I should have probably removed that. This was not better. Not at all. Yeah, but this is better, right? You saw just a black screen for a fraction of a second. Let's do it again. That's better, yeah. Much better. And what we can also do now is do something like this. Instead of set palette, we say fade in palette. And we will also do a fade out effect. Right before we return to text mode. Yeah, that's right. That seems good. Now we need to define these things. Yeah, well, okay. In the future episode we also need to refactor this main function, because it has taken on so many things. We'll put all the game code into its own function. But first of all, let's do the fade in palette function. It will take, I think, a byte pointer for the palette. And we will obviously need to iterate over something. And what do we need to iterate over? So basically, to fade in, it will take us a maximum of 64 steps, because this is the maximum amount of value that you can get for one palette entry, right? So we need to increment the value of every palette that we have. Actually, we need another palette. That's true. So we take a byte and we call it pal2, I think, of size 3 times num colors. And since we're fading in, we will use memset. Let's look up memset again. It's in the memory header file. It will take a pointer, a character, and a size. So the pointer is palette2. The character that we want to write is just a 0. And the size is 3 times num colors. And we don't even only need to iterate over these 63 steps, but we need to iterate over the palette every time. So for j equals 0, j smaller than 3 times. Oh no, actually not, but num colors, 256 colors. What do we do? First, for every auto iteration, we wait for the retrace, because otherwise this will be over so quick that you can't see anything. So we'll sync it to the vertical refresh, and then here we need to do something. What do we need to do? We need to write a palette value out to the VGA card, but not always. So let's copy this part. We don't need this. So basically we want to write the new palette out that we are incrementing from black to the actual palette. So j times 3 plus 0, this is the red value. Let's write that here. And here we want to write the index, which is technically not even necessary. We can move that here and just write 0. It will be auto-incrementing, so we just say please start from the 0th color. And here we use the green and the blue index. Green value, blue value. Okay, but this will only write out black values at the moment. So how do we get this to be better? We need to increment, right? So, and actually I think we might do it better than that. Because, so let's check that. If pal2 of j times 3 plus 0 is less than the original palette, j times 3 plus 0. So if we haven't reached the target value, then we basically just increment this value. 3 plus 0. Plus plus, this will increment by 1. However, seeing this, I would say we can save ourselves a ton of ifs and stuff and computations by just iterating over all the colors and not doing it in red, green, blue steps. This will be so much simpler because we actually don't care that this is red, green, blue. We just iterate over all the 768 values here. And this should work, right? So at a maximum of 63 times, we will wait for the retrace, tell the VGA to start at color 0, iterate over all 768 components, and if our current component is still less than our target component, then we increment. And then we write that value. Sounds good, right? So for this to compile, we need to define the fadeout palette function. But we won't do anything with this. And we have the fade in here and the fade out down there. So this should, in theory, compile. One warning, because we have unused parameter, but we don't care about that. So let's see. And it doesn't work. It's even worse, it hangs. Okay, where's our bug? Okay, yeah, never copy and paste. Always check your variables. So we were incrementing I. That's of course very stupid indeed. And yeah, it works. Did you see the nice fade in? Let's do it again. This is very nice, isn't it? So this is the simplest kind of fade in that you can do. Actually, more correct would be to compute the ratios of the colors and do a proper linear fade in, because this is more or less constant, because the acceleration is constant for every color. But it's simple enough and nice enough. As a homework, you can try to do this with ratios and stuff. Try to avoid floats if possible, because that will be slow. But yeah, maybe you can figure it out how to do that. The fade out will be pretty similar, right? So we will probably also have to let's just take this whole block, but it will definitely look quite different. So we can actually work on the original colors, but I wouldn't want to do that. We don't want to mutate them. So basically we can mem copy. And let's look up that function as well. So destination pointer, source pointer, and size. Destination pointer is pal, source pointer is pal2 is the destination pointer, pal is the original pointer, and 3 times num colors is the size. That's correct. So we will also want to do 63 iterations. We will want to wait for the retrace, output the 0th color for the VGA card to start over, and then go over all the colors. And if our pal2j is still greater than 0, we will decrement. We don't even need the original colors anymore. And then we will write the value. And I think this should do the trick. Nice fade in and a nice fade out. Now this is much nicer, right? And this is all done on a hardware level just by manipulating the color registers of the VGA card. So this is extremely fast. And if I were to take out the wait for retrace, let's do this, you will see it's very fast. You can, this is nice and slow, and this is extremely fast. And this is even in the simulation, it's slowed down, so On a real machine it could be like over in a fraction of a second. So I think this is much nicer. If you want to speed this up, you can do this only every other loop or something. But I think this takes just slightly less than 1 second because VGA is 70 Hz, and that's good timing, I think. Alright, so this is already quite good. We have probably a few minutes left, so maybe it's time to refactor this thing a little bit. Let's throw out the print that we don't need. And take out the game code, maybe. Let's do something that is called handle game. And we need some way to tell it if it's a new game or if it's running already. And it should return if one of the players has won or not. So we need some kind of return value. And by default it will be 0, which means game still going. Let's put this in its new line. And value 1 will be player 1 has 1. 2 will be player 2 has 1. And the 3 will be escape pressed. So this is like game was aborted. And we will return this return value. I will set it when the time comes. So, what do we need? We will need quite a bit of stuff. We will need players. And the initialization. We will not. So the player status and everything will be copied. I think I forgot to delete that, yes. So let's delete that as well. How do I delete with this? I don't know. I just press Ctrl Y until it's all gone. So the mode initialization and the palette functions can remain here. Also the draw background. Or can it? Not sure about that. But this stuff here is definitely, so we need to make these variables static so that they don't change, that they don't get allocated all the time. So if I weren't making these things static, they would be initialized every time we enter handle game and we would lose all state. But a static variable will just keep its value from function call to function call. And if this is a new game, we will need to run all this initialization stuff. And we don't want to do this every other time. Yeah, here, nice function to indent, auto indent will be nice. And yes, draw background, fade in palette, and then we can say handle game, and yes, this is a new game. And every other time it will be like this. Handle ball, draw player, something something. Every other time it will be like this, but this will have to change and we need a new game loop. So handle game and then while handle game is 0. Nothing actually. Turns or breaks if one player won or escape pressed. Alright. Instead of while handle game equals 0, you can also write while not handle game. But I'd like to rather explicitly check for the return values instead of doing some implicit bool conversions. Okay. No, I think we can actually take this here out. There's actually one thing we can do. Wait for retrace. I think this shouldn't be in the handle game routine. So we'll kick it out here. And we don't need this. So here we also do the indentation. Help. This was not what I wanted. So if keyboard was hit, then this and that. We need a keycode variable. And we don't need it down here. It will not be used. The string will not be used. The palette will be used, yes, that's fine. Look how short now our nice main function is. It almost fits on a screen. That's good. Functions should always fit on a screen, if possible. Yeah, this is a bit tedious. But nice code is nice code. And this is a very old IDE. Doesn't do auto-indent, doesn't do autocomplete, doesn't do syntax checking, and still people wrote great software with this. We don't, but that doesn't matter. So here's this spurious brace, curly brace, handle ball, store player, draw player, something, something, something. Okay. If someone key character was 1xb, was it? I'm not quite sure. Let me double check. Yeah, that's actually correct. Then we can already return 3. We don't return anything else right now because we don't have the game over code. We'll do that in the next episode. So this should in theory work. Let's see if it compiles. Might be some problems. One error. Too few parameters. Yeah, handle new game. 0. Okay. See if it works. Yeah, this is nice. Okay, I can quit, but it's well, this is lovely. Okay, we get stuck here because we call get character. Okay, do we? No, that should actually not matter. If keyboard hit, then it does everything like that. Oh, look at that. We did something stupid. Yes, I think this should be in here, this should be in the initialization, because the very first time we already need to store whatever was under there. But that should not matter. Yeah, this just looks weirder because we restore and I still think we do something wrong with the get character. Okay, fixed it. So seems it's already too late for me to think straight. So the structure of the code is now as follows. The handle game routine knows if it's a new game, then it will initialize all the player structures, store the background behind the player, so we restore not garbage, and then it will immediately restore, because this is much easier than doing any other tricky stuff. And this is important that it happens before the keyboard hit, because then the animation will actually work. Then we check if a keyboard was hit, but let's say it wasn't, so we exit, and here's where my stuff was wrong. I accidentally put the handlebar and store and draw stuff inside the brace, so it would only happen during a key press. With this, again, being outside of this loop, it will simply work. And we have refactored our code so that it is much easier to understand, I think, although I didn't just now. But we have one handle game routine which does all the game stuff, game logic. We have a smaller main function now which does this stuff, and in the next episode we can then go on to print the score, to keep track of the score and say when the game is over and present a very small game over screen. And that's where we will have a more or less complete game, because it will have rules, it will have game state, and it will have an end with a definite winner of the game. So I hope you learned something here, and the code will be on GitHub as usual. You can read it up, you can play around with it and make it better. I hope you enjoyed this. Share, like, and most important of all, please subscribe to my channel if you like this, and see you next time.